What's going to be different here is how you were probably taught to find equations of lines in grade 10 math, and even how you found equations of lines, linear functions or straight lines, in grade 11 and 12 is probably not what we're going to be doing. In grade 10, you were taught to find equations of lines in two ways, and then your teacher most likely said, let's always do this. And the one that your grade 10 teacher neglected is the one that we want to do. And that isn't a criticism of the grade 10 teachers, it's because that's the way we do things in grade 10. So we're going to be determining equations of linear functions, knowing characteristics of the line, and then interpreting slope as what we call a rate of change of the dependent variable with respect to the independent variable. To begin with, a very broad review of linear functions is that a linear function is any function that can be written in the form f of x equals mx plus b, where the equation of the graph of the function is y equals mx plus b with a slope of m and a y-intercept of b. And this is probably the only time anybody's ever told you a meaningful difference between writing f of x equals mx plus b and talking about y equals mx plus b. They're different things, it turns out. F of x is a function of x. It's a mathematical operation. It's an equation that you can use to find the output, which is f of x, if you know the input. When you start talking about plotting it on a graph, you graph f of x. You graph rather y equals mx plus b. That's why in your graph it says y equals f of x. It's telling you that to find y, you use this function. It's a very subtle difference. I wouldn't worry about it, but some people wonder why I've worded that way. The slope of a line segment containing those two endpoints can be found using y2 minus y1 over x2 minus x1. Again, this is very basic grade 10 math. Delta y over delta x is maybe a simpler approach. I don't like that. I would rather go y2 minus y1 over x2 minus x1. Simpler is not always better. By simpler, I mean if I were to teach a grade 9 student what about slope, they need to know, I would say delta y over delta x. I'd get them to draw a triangle, I'd say rise, run, all that stuff. So I do have a triangle on here to connect y2, y1, x2, x1 to delta y and delta x, but the bottom line here is if you take the y coordinate minus the y coordinate, you get the rise. If you take the x coordinate minus the x coordinate, you get the run. I think you know this, but I will just tell you. If you end up taking this y coordinate minus this y coordinate in the equation for slope, then you had better, in the equation for slope, take this x coordinate minus this x coordinate, right? You have to subtract in the same order. You can't take y2 minus y1 over x1 minus x2. And in this course, very rarely do we actually put labels like y1, y2, x1, x2 on things. The slope of a line should be thought of as the rate of change of y with respect to x. What that means is it's meaningful. And in order for me to explain this to you, I have to use specific examples that are practical. So for example, if I had a graph in which the variable on the vertical axis was dollars and this was minutes, then the slope is going to have units of dollars per minute. So let's imagine that the slope has a value of 14, would be $14 per minute. And that is considered a rate of change of money with respect to time. It's telling you how money is changing relative to time. And more often than not, in your past anyway, it's always been with respect to time. Like, you think of your physics graphs, you have displacement and time. It's the rate of change of displacement with respect to time. But it doesn't have to be. It can be anything. It could be that you have a sphere which is melting. And this is the volume, and this is the radius. And let's not worry about whether this is a straight line or not, because it will not be. But let's say that the slope at a particular point in time happens to be negative 48 numerically speaking. Well, what is that? That's the rate of change of volume with respect to radius. So it would have units of maybe centimeters cubed per centimeter. It's not right, it's not a good idea to cancel one of those centimeters and say the slope is centimeters squared, because centimeters squared is area. And the slope doesn't represent area. The slope represents rate of change of volume with respect to radius. So this would be telling you that the volume is changing at a rate of negative 48 cubic centimeters for every centimeter change in the radius. Okay. So that's what we mean by rate of change of y with respect to x. Now, in order to determine the equation of a linear function, you do need to always know two things. You can burn this into your memory. The fact of the matter is, regardless of the method you're going to use, you need to know the coordinates of a single point on the line and the slope. And I will show you both methods, and then I will tell you which method I prefer and which method I recommend. You're going to then use this formula. And this is a little awkward, I get this, because I've just gone through explaining that the equation of a linear function is this. And the graph of the linear function has this equation. And that's how we characterize something as being linear, but that's not the equation we're going to end up using. I don't know if you recall, I hope you do, but linear equations or linear functions or linear relations can also be expressed using this. Ring a bell? Maybe not. Well, that's what we always want to use here in calculus. We don't want to write y equals mx plus b. I'll give you a quick illustration here. If you had a linear equation or function, whatever you want to call it, of that, you can multiply everything by 3. You can zero it and get x minus 3y minus 21 equals 0. I'm telling you this is preferable to this. Okay. So what we're going to do is we're going to use this. It's called the point slope formula. How many of you remember seeing that in grade 10? It's not very many, because you use it. In fact, in grade 10 they call it the point slope form, which I've always disagreed with. But you use it, and then all of a sudden it disappears from your world. We're going to become more familiar with it in a couple of minutes. Just finally, one other thing before we get to some examples. You need to know that we always talk about slope being positive or negative in terms of a line moving to the right. It's always to the right. And what I'm telling you is run is always positive. And if the rise is positive, the slope is positive. And if the rise is negative, the slope is negative. So what that means is this is a negative slope. Because if I were to start at a particular point and take a positive run, then I have to take a negative rise. So left to right, if a ball rolls downhill, it's going to be a negative slope. On the other hand, left to right, if you have to roll the ball uphill, it's a positive slope. And finally, you should know that that is a slope of 0, and this is a slope that's undefined, although we can get away with saying it's infinite. So does anybody have any questions or comments about anything I've talked about with regards to linear functions? All right. Equation 1, determine the equation of a linear function that passes through those 2 points. Well, I've told you that you need to know 2 things to determine the equation of a line. You need to know the coordinates of a point, and you need to know the slope. Well, we know the coordinates of a point, and it doesn't matter, everybody. It doesn't matter if you use the point 2 comma negative 4, or if you use the point 4 comma 6. Take your pick. I'm not asking you to write both down. I'm saying it doesn't matter. I'll go with the 4 comma 6. It really doesn't matter which point you use. So how are we going to find the slope? Well, you're going to use your slope formula, right? So your slope can be found by taking the y-coordinate of one point minus the y-coordinate of the other point over the x-coordinate of that first point minus the x-coordinate of the second point. Now this first example is very simple. It's not even going to have any fractions because we get for a slope 10 over 2, so the slope is 5. And clearly, even if the point that you put in your list is 2 comma negative 4, you're still going to use these 2 points to find the slope, and you're going to get 5 for a slope. And I'm about to explain to you why I don't like them calling this formula the point slope form. Okay? If we go with this, which is what I said we're going to go with, I'm telling you that you should be using this formula which is the point slope formula, I like to call it, to determine the equation of the line. Now in this formula, x1 comma y1 is a point known. It's an ordered pair that describes a point on the line. On the other hand, in this formula, x comma y is any point. In other words, x and y are the variables. We don't put numbers in for them when we write the equation. We want an x and we want a y. So what this becomes is y minus the y-coordinate of 6 equals the slope times x minus the x-coordinate. All right? Good? Okay. What if we did the same thing here with, keep going in the wrong direction, with this one? Well, then we would have y minus y1 equals the slope times x minus x1. We would get y minus negative 4 equals the slope times x minus 2. Fair? In other words, you agree? Here's the issue I have in grade 10 math. In grade 10 math, they tell you that this is the ending point when you come up with the equation of the line. So this is the equation of the line. They will say that's the equation of the line. But the issue I have with that is it looks entirely different than this, right? So in fact, when you use the point slope form to describe a line, there's an infinite number of answers. But these are all the same. These two are the same because if I expand this out and add that 6, I end up with y equals 5x minus 14 if my math is correct. Or 5x minus y minus 14 equals 0. Which is preferable, okay? But what if we expand this one out? Well, I end up with y equals 5x minus 10, and I subtract that 4 to the other side. I get the same equation, which grade 10 students' eyes light up. Like, what? You get the same equation? And you do this with 5 or 6 different points, and you always get the same equation. That's why we're doing it. We want to find the equation of the line. So you still end up with 0 equals 5x. I missed my, nope, I didn't miss my y. Minus y minus 14. And that's the answer to the question. Let me demonstrate to you probably how you would find the equation of the line in even Math 30. In Math 30, what you would probably do is say y equals mx plus b. And this is a legitimate solution. There's nothing wrong with this. But in the second example, I'll show you why it's not a preferred method. And you would say, I know the slope is 5, so the equation is y equals 5x plus b. And I have what I like to refer to in high school math as a missing parameter. And in order for you to find a missing parameter, you load in an ordered pair. So we can load in for x2, and for y we get negative 4, so you end up with b equals negative 14. And then you can say y equals mx plus b, and it's the same equation. All right? And you can, I'm not going to, from this point right here, well, I'll write it down. From this point, we'll do it with this one, where you have y equals 5x plus b. You know, you can feel free to put 6 in for y and 4 in for x, and convince yourself you'll still get a y-intercept of negative 14. Okay? But this is the way to go. This is what we want to do. Any questions with A? All right, B. So this is a linear function. We have the equation of the function, and you might want to think of it this way. I don't care if you set it equal to 0 or not. But the question is, if x is decreased by 7, then how does y change? I want you to think about that for a minute or so. So you go from one point on the line to a different point on the line, and what you're doing is you're going 7 less for x. What happens to the y coordinate? And I know I've kind of set it up in saying it and describing it that way to try to lead you into solving this as if you're going to solve it by looking at the graph, by solving it as a puzzle almost. But you're not. We know the slope is 5. But 5, which is the slope, is the rate of change of y with respect to x. And another way to write that 5 is the rate of change of y with respect to x is to write that the slope is the change in y over the change in x. And you're told the change in x is negative 7. So what we can do is put negative 7 in for delta x. I mean, you're not told delta x is negative 7, but you're told x decreases by 7, so the change is negative, and the magnitude of the change is 7. Finding delta y from that little equation is pretty simple. Delta y is equal to negative 35. So the answer is, if x is 7 less, y will be 35 less. So y decreases by 35. This is not, none of what we've done Wednesday, yesterday, or today is in the realm of being on an exam. This is just warming our brains up and giving us the right skills for what's to come. Any questions with B? All right, determine the equation of a line perpendicular to 3x plus 4y minus 10 equals 0, and also passing through a particular point. So the line we want to know the equation of will have a slope that we need to know, and it will pass through, well, it's going to pass through an infinite number of points, but we need to know the coordinates of one of those points. Well, we're told it passes through 2, negative 5. So we need to determine the slope of the line. And I believe there I've given you that blurb from grade 10 math, which says parallel lines have equal slopes, but perpendicular lines have slopes which are negative reciprocals of each other. Can you confirm for me, Alex, does your question say perpendicular? Okay. So this is not the line we're after. Right? It's not the line we're after. The line we're after is perpendicular to that line. And we know the relationship between slopes that are perpendicular. If you have L1 perpendicular to L2, if I tell you the slopes are negative reciprocals of each other, then that means the slope of L1 multiplied by the slope of L2 has to be equal to -1. And I'll give you some illustrations here. You don't have to use this statement to answer the question. But if I had slope of L1 is equal to -4/5, the negative reciprocal of that is +5/4. That's what a negative reciprocal means. It means you reciprocate it and you change the sign. If you take these two slopes and multiply them together, you get -1. That's all I'm saying. Okay? So if we knew the slope of this line, we could take the negative reciprocal to determine the slope of the other line, and then we could be off and running. How are you going to determine the slope of the line 3x plus 4y minus 10 equals 0? Does anybody know? Well, we're going to put it into the form y equals mx plus b. As much as we don't use this formula to determine an equation, we can certainly use it to determine a slope. Right? If I subtract the 3x and add the 10 to both sides, I get 4y equals -3x plus 10. I think most of you would see immediately that the slope of this line is -3/4, because I still have to divide everything by 4. When I do that, I get this, plus, quite frankly, I don't care. My work here is done, right? Well, not really done, but this part of it's done. Now I know the slope. But if you want to, I guess this is 5/2, 10 divided by 4. So the slope of this line that we don't want to know the equation of because we already know the equation of it is -3/4. The negative reciprocal of that is 4/3. And now we're off and running. We can use the y minus y1 equals slope times x minus x1. So we'll have y minus -5 equals the slope, which is 4/3, times x minus 2. And again, this equation down here, I know this is not what we're after, but this is called the slope y-intercept form of a linear equation. It's riddled with fractions, and we don't like fractions. We would much rather have an equation in this form at the top, which is called general or standard form. At this point in time, we can multiply both sides of this equation by 3 and get 3y plus 15 equals 4 times x minus 2. Are we okay with that? Okay. We can multiply that 4 through and get 3y plus 15 equals 4x minus 8. And from here, we're just a little step away from getting the equation in standard form or general form, whatever you want to call it. We tend to use both those terms in high school. It's 4x minus 3y, I guess minus 23 equals 0. How's my arithmetic there? I think that's okay. And we're done. But I want to illustrate to you I think why this is preferable. Quite frankly, I don't care how you get here. I really don't, other than what's the answer, right? So what you could do is you could say that the slope is 4/3 and it passes through 2 comma -5. And you could say that means y equals the slope times x plus the y-intercept, and treat this as a missing parameter. There's nothing wrong with doing this. So then you would put -5 here, 2 here, and solve for b. But to me, this is more thought now. I have to think about fractions, and I know you can say, well, I have a calculator. I have 2 students from last year who are in engineering type programs right now, and they are not allowed calculators in post-secondary. They're just not allowed to use them. You never know who you're going to get as a prof and what kind of rules they're going to set. So to me, I mean, I can figure out what this is. This is -5. This is 8/3. Well, now I got to figure out what -5 minus 8/3 is. It's not that bad. It's -23/3. Let me just double check that. It's -23/3. So then you would say y equals my 4/3 x minus 23/3, but I want to get it into standard form, so now I have to multiply everything by 3. I think this is more work. And I think you will agree after a while, after doing this y1 and a general point approach, in other words, using y minus y equals slope times x minus x, I think you'll agree it's easier, it's cleaner, it's quicker. We don't want fractions, though. You know, is this equation incorrect? No. It's not as useful, though. Like if we had a system of equations, you would much rather have ax plus by plus c equals 0. Monday, questions 1 to 6 and 11 and 12 are, maybe even 6 as well, are wordy kind of problems where you have to try to find a connection between a scenario and a linear equation.